Good morning, Dan. Welcome back to another episode of Circuit Talk, and thank you for taking the time today.
Absolutely, Ross. Thanks for having me.
It's a pleasure to have you, Dan, as always. Before we kick off, I thought I should say a few words about you, Dan. Dan has been not only a good friend for many years, but also he is the president and founder of Trusted Strategic Solutions today, with deep insights into the semiconductor ecosystem, working with the defense side of the business as well as the commercial side of the business. He brings a very unique perspective to the industry. And before starting his own company, Trusted Strategic Solutions, Dan was the chief strategic officer for the Office of the Secretary of Defense in the Defense Microelectronics Activity, which is based out in Roswell, California. So, Dan, thank you again for joining us today.
It's always a pleasure speaking with you. I do have to emphasize the longstanding friendship, which has really been built off of, quite a bit of both discussions where we agree and discussions where we've challenged each other's thoughts. Mm-hmm. But what I do have to say is that in each of those capacities, I think that it is not only strengthened our relationship, but the efforts that we put forward.
Absolutely. Dan, so I want to kick off this discussion by asking you, from your perspective, you've seen the national security side of the business, and you also understand where the commercial industry is going. But let's dwell on the national security perspective. Can you highlight where we stand as a nation on that, on the terms and the needs that we have right now for taking care of our national security? And has something changed in the recent past?
Yeah, absolutely. So within the Department of Defense, there had been quite a bit of emphasis on secure electronics for a number of years. Many thought that was the direct tie into national security. And quite frankly, it sounds obvious, right? You want to have secure electronics in order to have protection in a national security perspective. But the take that I have on this is a little broader than that. I think that there's really three categories of emphasis that impact national security. One is availability of electronics. Are we able to acquire the electronics that we need, not only for commercial aspects, but for the programs that we have that protect our national security? The second one is sustainability. Programs, specifically defense programs, last for quite some time. I mean, take, for example, the B-52. At the end of its service life, it will have served the government for over 100 years. If you think about the original electronics that went into that and whether or not they're available today, you and I both know that within our industry, technologies last about 10 years. So having something like a system like the B-52 last for over 100 years, sustainability is directly tied to national security. And then, of course, the first topic that I brought up, which is the actual security aspect. How do we minimize malicious insertions into critical components? How do we protect our IP from the adversaries that are looking to leap ahead of the world and specifically the United States in technology development? So I think that the aggregate of these three areas really tie into the protection and the importance of national security in that particular order: availability, sustainability, and security.
No, that's actually a very, very valid point that you make. And has something changed in the recent past? I mean, you've seen the industry from the defense perspective for a while, and has there been any transitions recently that you think make this a much more urgent situation for us as a nation to deal with?
Yeah, it's primarily about how the United States government has been able to influence the semiconductor community. If you look, for example, in the 80s, the United States government helped to dictate quite a bit of the direction of not only the R&D investments, but the production of critical microelectronics. The BISIC program is a great example of this. You fast forward to today, and the Defense Department is less than 1% of the overall microelectronics that are purchased commercially. So that is one major change that has happened within the ecosystem that the Defense Department is operating within. The second is the fact that it is a global supply chain. And this is one of the emphasis for having the CHIPS bill. Right now, the United States and the rest of the world relies on overseas manufacturing for a primary amount of the components they integrate into their systems. So understanding that ecosystem and whether or not we're able to work with allied countries or have to create protection mechanisms that help minimize our reliance on overseas manufacturing is highly critical. So I'd say that those two areas are the most recent items, but also the most critical that have impacted the Defense Department and national security on the way that they influence and acquire microelectronics.
Mm-hmm. Yeah, makes sense. And thank you for that. How much of a component of the commercially available electronics do you think go into the interests of the defense side? I mean, I understand that the defense side of the business has a lot more customization that is valued many times, and it is necessary for them for their applications. But I'm sure a lot of the products are coming off the shelf. The off the shelf products, what percentage do you think roughly there is that is used in the defense side of the business, including the DIB, the defense industrial base companies?
Yeah, and this is a challenging question because you get into many of the different requirements that the United States government has for the components they have. Even if it is commercial off the shelf, the stringent types of testing, evaluations, et cetera, that are needed for the end applications vary from system to system. So what is needed for a national security space satellite is very different than what is needed from an Abrams tank. So leveraging the commercial off the shelf is a direction that the United States government is working to go down, but it also compounds the problem, primarily from a supply chain perspective. You look at the number of hands that have touched this, and the rising amount of counterfeit components that are integrating into many of the different systems, not only in the Defense Department but around the world. I mean, if you go to Shenzhen, China, you look at one of the largest counterfeit ecosystems in the world, where they're literally washing components in riverbeds and the such to sell them on the second market and things of that nature. So, but the root of your question is how much are the commercial off-the-shelf components not only influencing but impacting the overall systems that they're integrating in, and the influence of the highly specific types of components, ASICs, for example. So I would say that the United States government, when they have the opportunity, relies on commercial off-the-shelf components. It's something that is just readily available, and the way that defense acquisition works is that they look for lowest cost for the available solutions that they're looking to acquire. So I'd say that a majority of them are commercial off-the-shelf. At a minimum amount, though, the most critical are the ASICs. And the United States government has done a pretty good job in working with its internal ecosystem and creating protected mechanisms for state-of-the-practice legacy types of ASICs. One of the challenges they have right now, though, is how to acquire state-of-the-art 7 nanometers and below.
Understandable. That's a complex problem because you want security and you want proof of provenance of your systems and the components that go into systems. At the same time, the supply chain is so global that it is very difficult to actually assure that every one of those components comes from a known source and its provenance can be proven. And with all that, you have malicious software and malicious components getting in there. It's a really challenging problem for the Defense Department, and I can appreciate the complexity that they're dealing with. Now, I think the Chips and Science Act is a boon in some sense for all sides of the semiconductor industry, and it's also hoping to solve some of these problems that the defense industrial base as well as DoD face today. With that backdrop, where do you think the commonalities are? And that's the genesis of my previous question of what percentage or what level of components from the commercial side, the COTS, if you will, are used on the defense side. I mean, is there some degree of commonality that we can hope to achieve and satisfy the needs of the DoD while working on the commercial side as part of the CHIPS Act?
So the short answer, I believe, is yes, but not using the same types of processes that we have become accustomed to. And I'm going to give two specific examples here because I think that we're, as a nation, in an inflection point. I think that this is something that we need to challenge the way that we operate each of the different steps of not only coordination, but integration of these critical components. So the first item that I would say is we need to increase the amount of leverage we have from a digital architecture, or digital aspect of things, and not just from a design perspective. I'm not just describing EDA capabilities, which are extremely critical in the overall ecosystem, but I would say we need to take it even further. There is a number of initiatives right now that are working on aggregating all information from a digital aspect. I've heard terms such as the Semiverse, for example, as a way to buy down the overall differences at each of the different stages of the supply chain. in creating this kind of semiverse or this digital architecture, digital ecosystem, it allows for communication and coordination amongst not only the semiconductor suppliers, but also different parts of the U.S. government, whether it be the Department of Defense, Department of Commerce, Department of Energy, et cetera. So I think that will help with the information exchange, but also by default will create a number of opportunities for us to protect our IP, which I also think is highly critical into this digital ecosystem. The second piece to this, and this goes more towards the coordination, is, let's be frank, the U.S. government is a difficult group to work with. Every single office has a representative that is speaking on behalf of the U.S. government, or at least that's what is projected out. So I think that having a front door organization or a front door office at each of the different departments, whether it be Department of Defense, Department of Commerce, Department of Energy, et cetera, for knowledge centralization is highly critical. And within this, that same front door office is able to help coordinate and communicate each of the particular strategies and roadmaps that are needed from each particular department. In having that, I think that creates an opportunity not only for coordination amongst the U.S. government, but also coordination with the semiconductor base. And we've seen this quite a bit with what the commercial industry has done. I think it's time now for the U.S. government to act like the commercial side of the house and create these engagement models that buy down the overall risk and create a very streamlined set of direction that the community can go ahead and work towards.
And how do you propose, or what suggestions would you have for better coordination between DoD and DOC entities as we move into the CHIPS Act and the implementation of the CHIPS Act?
Yeah, I would say on the foundation of those two items I just described there, the thing that I think is extremely critical at this stage is having these roadmaps and overarching strategies not only developed, but refined on a regular basis. You and I both know this. Technologies change on a quite frequent battle rhythm. So in having that type of frequently changing types of technologies, it's important that each of these strategies, roadmaps, et cetera, keep up with the overall needs. Plus, the Defense Department specifically, that's not only the example I'll use, but what I'm most familiar with, they have to deal with traditional and irregular types of warfare challenges. Having that paradigm of very different types of needs, being able to communicate this with the other departments in ensuring that where there is commonality to bring down the overall risk, we're able to do so. So I think that those types of items are not only essential, but will help with the overall coordination amongst each of the different departments.
Thank you. As contemplated now, the DoD microelectronics commons and the plans that the DoD is unveiling are all quite exciting, and there's a lot of interest in participating in those programs and activities. And I was curious if you had any thoughts or any guidance on what role, from your perspective, prior to starting your company as the Chief Strategy Officer, what role do you think that these microelectronics commons hubs could play in the ecosystem? I believe that many of the technologies that the Defense Department has been working on in the past have become mainstream technologies, and defense always kind of leads in many ways in the contributions that they have made to the commercial side. So what role do you think that the commons would play as we go along, and how would you translate the technology coming out of the hubs to commercial space, either for the defense purposes that are necessary, or even eventually into the mainstream commercial space, so that there is volume and cost reduction for defense needs of the country?
So big question here, and I'm going to unpack a few different items. Some of them are thought pieces, as we continue navigating this, but others are recommendations. Most important piece as we navigate the ME Commons overall initiative is, how do these hubs not only work with the commercial industry, but protect their IP? I think that IP protection and IP transmission is going to be the foundation on whether or not a microelectronics commons is successful. The secondary piece here is we need to make the investments that are coming into the microelectronics commons not feel like $2 billion. It needs to feel like $200 billion or, $500 billion. And the reason I say it that way is collaboration in the ecosystem is highly critical. Though the projected requirement right now is just to have regional hubs, I think that each of these regional hubs must not operate within their own silos. If there is a Midwest capability, it must have communications with the Southwest capability or the East Coast capability or whatever the regions end up turning into. Because this goes back to the earlier comments. In order to succeed here, we need to collaborate in common areas, and these commonalities, like we were describing with commercial off-the-shelf types of components, but still applies here to the hubs, will buy down our overall risk. It'll allow us to not make the same mistakes twice. Lessons learned are highly critical. So if we're able to have a network of these hubs all communicating in specific areas that help us to make the $2 billion feel like $200 billion, then that's a huge benefit. The other one is the way that the U.S. government from the ITC is treating their tax incentives. And I think tax incentives as a whole is a huge opportunity that the United States can leverage. It leans towards certain size companies and does not really help other size companies. And the larger companies are the ones that I think that don't really get the same type of benefits associated with the tax credits that are being proposed today. So in order for us to stay competitive with some of the other overseas R&D initiatives, integrating the appropriate tax incentives that reflect the internal commitments and internal investments that are coming from these larger companies will put the United States and the ME Commons in a position to not only succeed but continue succeeding from a longer term perspective. The final piece, and this is more of a thought piece that I would state on this, is in order for there to be a major influence here, the ME Commons must not look at the here and now as the only objective in solving the problem. There has to be a long-term post-ME Commons, post 5-year funding on how this ecosystem not only thrives but survives. And how do we continue inserting not only the technology capabilities, but the influence from the world-class experts and opportunities for funding so that the ME Commons becomes a staple within the United States opposed to a 5-year program.
Right. Very true. I think the sustainability and whether to thrive or to make these entities survive is a big question. And that is true for NSTC. That's true for ME Commons. It applies to many of these entities. What recommendations or what suggestions do you have in how these two entities could work together? The NSTC, as it's being contemplated, is an $11 billion program that the Department of Commerce is fashioning. And then DoD is working on the Commons, which is approximately $2 billion. And you're correct in stating that these things should be just the catalyst money or the money for the catalysis that we all hope to see and transform the national semiconductor landscape. And they should be influencing 200 billion to 500 billion or even much more. And at the same time, thrive the ecosystem and make semiconductors more of a primary technology that the US dominates. So I personally think that these technologies or these two options will have to leverage the joint technology base that they have. And I'm very curious to hear your recommendations and how these two entities could work together to achieve that.
Absolutely. So the foundation is there with the way that these are structured, but now the implementation phase is needed. So what I mean by the foundation is you look at the technology roadmap or the technology development cycle that each of these is focusing on. The intent here is that they're naturally supposed to transfer capabilities and technologies from the ME Commons to the NSTC. So how do we ensure that this happens? Many of the different people that are proposing to each of these different capabilities are focused in on the science, and rightfully so. I think that is where we're looking to extract the highest level of talent possible, so that we're able to have advanced packaging capabilities or better refined approaches to heterogeneous integration or compound semiconductors, whatever it may be. The piece that I think that will allow this to happen is the government observing that tech transition has not been a strength in many of the funded activities that they've had, and have a specific capability established to work on that in ensuring that there is success from the ME Commons to the NSTC. I think that once the opportunity is presented on different ways for technology transition, then that should be presented to the performers of each of these different groups to work within to ensure that the technology transition is not only successful, but also has a path to integration into the end systems. We can have technology seduction for as long as we want and continue funding different activities, but if we're not looking at the end requirements associated with each of the technologies that we're investing in, then we're just tinkering in the labs. And I think that though there is a need for some, highly exploratory types of R&D, that cannot be the overall intent with the CHIPS initiative. So I think that at this stage, we are in a great opportunity for the U.S. government to stand up and put forward a very specific technology transition plan that allows the performers of the ME Commons to work not only with the NSTC, but by extension, the funded activities within Section 9902 for building out the manufacturing capability here in the United States.
Right. That's a great vision. And what you're saying, if I could sort of rephrase it or summarize it back, is you're saying that output of the microelectronics commons should have a metric, a success metric of how do you transition it from the commons to a core that the Department of Defense is calling, and also to part of the foundry ecosystem through the NSTC. So leverage the NSTC as sort of the common vehicle in between that helps to take these technologies from lab to fab at the end.
I really believe it's the glue. If the NSTC is not creating an on-ramp and an off-ramp for the technologies, then we're going to have a self-created valley of death, which is a very common term in our industry that people use. But we will be creating this by default without having the plan. So in order to avoid this currently non-existent yet pending problem of a valley of death, which the NSTC can solve, they have to be the glue between the two.
Very much so. I think I agree with you. The other question I had was, if you had a choice, is there one specific topic, that the Commons or the NSTC should be pursuing right now as a topic of national importance?
Absolutely. So I look at the supply chain and I look at the reliance on overseas manufacturing that the U.S. has. At the root of the CHIPS initiative, there is a requirement for all manufacturing to minimize its dependency on overseas manufacturing. And an example that is used quite regularly is if a tsunami was to hit a specific location in the world, how can the United States continue operating not only as an ecosystem, but protecting national security? The major void that I see in all of the investments that are going on right here, and I don't want to downplay the importance of the investments that people are highlighting as key capabilities, but when you have 99% of all OSAT capabilities, and for those of you that are not familiar with it, OSAT is outsourced semiconductor assembly and test. 99% of that is done overseas. That creates a natural challenge for the United States if said tsunami was to hit a particular region of the world. We can have all of the investments in design capabilities, in fabrication, etc. But if at the last stage of all of this, we do not have the domestic packaging, assembly, and test capabilities, it is going to be, yet again, a problem that we won't be able to overcome. And I think that the two key items that need to be addressed in doing this, because that's the problem thesis, the two is how do we overcome the inexpensive labor that is found overseas, which keeps them highly competitive, and by default creates a pricing structure that usually allows them to win the bids opposed to the United States. So finding unique mechanisms in leveraging what we have here in the United States to create an OSAT capability, I think, is the primary challenge. And then by extension, the other portions of the supply chain that are not necessarily highlighted in the current major press releases that are coming out with those that are trying to attract CHIPS funding.
Yeah, that's very true. And thank you for that. You touched upon supply chain, and I wanted to sort of double click on that a little more. The semiconductor industry supply chain is so global. And to what extent should we be considering global outreach, or at least with allied global outreach, if I may say so, part of this whole rethinking that we're going through in the nation?
This is an excellent question, and I think that this is something that I know you and I have thought about and wargamed. What the opportunities are and the such. First and foremost, we have to recognize that we do have allies and countries that have the same concerns that we do with particular overseas manufacturing. I think that we leverage existing relationships that the United States has established in supporting some of these allied countries. An example of this is what we did with the DMEA Trust program, where we leveraged the Five Eye relationship for said program. So it allowed us to work with Australia, New Zealand, Canada, and the UK in concert with the United States to create an ecosystem of secure manufacturing for the trust program. But the extension beyond that, I believe, is required. Relationships with the Netherlands, for example, with the capabilities that they have with tool manufacturing. The Japanese, who have been very willing to partner on multiple different R&D activities, and a variety of other countries. I'm only listing a few here right off the cuff. South Korea, another example, with their major investments in memory and the opportunity for the United States to work with them in this ecosystem. I think that we have to be very tied in with one department we have not talked about so far today, which is the State Department. How do we ensure that the needs from Department of Energy, Department of Commerce, Department of Defense work alongside with the State Department to create the appropriate, not only mechanisms for us to do work together, but strengthen the relationships that we have with all of these different countries. It really is a global challenge. We are a part of the ecosystem, though a large part of the ecosystem, but we cannot ignore the fact that in order to be successful on this, our investments alone will not change the paradigm and the concerns that we have as a global economy in the semiconductor space. So I believe that is the immediate next step that has to happen.
So Dan, it is exciting that we do need to partner with multiple countries around the world to strengthen our supply chain and to make it much more resilient on one side. But on the other side, we also want to strengthen domestic manufacturing and domestic capabilities. So in some sense, there is a natural tension between these two objectives. And if you will, we are trying to come up with an industrial policy for the first time with semiconductors. And do you see any dissonance coming between the two, and how would we reconcile the two?
So that's an interesting question, Raj, and I think that we are in a position of a crawl, walk, run in solving this problem. First, we have to understand where the areas of opportunity for collaboration are with our allied countries. I think that is first and foremost. We have a good understanding of some. I think that the continued dialogue with those that are identified as being, core to the success of the United States is critical. Then by gathering that information, we roll that out into these roadmaps that I described at the onset, and we present this in a fashion that allows us to be collaborative partners with the allied countries that we described. One of the things that we cannot do, and this has happened far too often, is take the opportunities for collaboration and put them into a silo in our defense departments or our whatever U.S. government department you want to choose, and not project this out. I have seen other countries very willing to share their roadmaps, their thoughts, their co-investment ideas, etc. We have to treat this as a partnership in order to be successful. Once again, doing it alone will not happen.
Right, and at the same time, we are also trying to sort of give a boost to our domestic industrial supply chain in this entire system. If you look at where we need to go, and you touched upon OSATs and you touched upon some of the manufacturing capability that is necessary in the country, do you think that the current policies are going to help us achieve those objectives, or are there any other additional activities that you would recommend to achieve these objectives while making sure that this partnership that you alluded to with friendly countries is still going to be retained and is still maintained?
So yes, I think that there's current mechanisms that we can leverage, and I think that there's current mechanisms that need to be developed. I think that right now, an example of this is what is coming out from the White House, and there is a list of companies that have been identified as those that we have to stay away from, and projecting that out to the rest of the world on where we're drawing the line in the sand is critical. But then by extension, we need to work with the countries that are coming in and saying that, yes, we are going to cut our ties off with mainland China specifically, and we are going to work with the United States. I know that there have been a number of talks that the South Koreans have had with the U.S. government in showing their commitment to the U.S.'s direction. So how do we roll their commitment into a set of policies that will ultimately allow us to exchange information back and forth, and then collaborate as two nations. Another example of this, and this was done under the former administration by the former Undersecretary Miss Ellen Lord, who created a memorandum of agreement between the United States and the Japanese on specific R&D activities that both sides felt were opportunities to not only strengthen the existing relationship, but forge an alliance in new technology approaches that were not already established. So I think that continuing down this path is highly critical. I think that we do not have enough of the connections today. We need to navigate them in a very cautious manner, but at the same point, there are countries that are clearly showing that they are willing to make the investment and co-invest with the United States to achieve that ultimate goal.
Talking about the investments and the current climate for interest in making these investments, I was wondering if you had a perspective on whether this current political willingness to invest or co-invest has strength and legs in the long run. I mean, part of the reason why we are doing this is also the geopolitical situation and the tensions that are brewing all around us. So if these were to disappear, would the movement that we have within the political circles still be intact?
So interesting question, and I'll tie in a few thought pieces here that I think need to be considered given the political movement as you described. Going back to the first piece that I had mentioned, not only investing today, but also strategic planning for the future. What does the post-chips strategy look like? I think that once again is a topic that needs to be not only refined, but started immediately. The second is kind of wargaming the overall situations that we know we are highly dependent on. What is the United States going to do if Taiwan was hit by a tsunami? Not only TSMC, but the OSAT capabilities that are present in Taiwan. How do we handle the loss of access, whether it be short term or long term? How do we as a country ensure that our economic security is not jeopardized because of this loss of access? And with economic security, by extension, is national security. The final one is how do we navigate with the uncertainty of government budgets, specifically the defense budget? We have been very reliant on having defense budgets, not passed on time. So having continuing resolutions, having sequestration, those different things within the last 10 years have been realities that the U.S. has been faced with. So if there is a lack of funding that happens, how can we ensure that the CHIPS initiative doesn't fall by the wayside because of this? There's too much capital and political capital that many have put forward in ensuring that this gets started. To have something hung up either by Congress or by other mechanisms is going to only weaken the United States, its microelectronics capability, its national security, and its economic security. So I'd say from a set of political movements, those are areas that we have to be aware of quite a bit. The other piece is what are the ripple effects that happen from different types of conflicts that, around the world. Those different conflicts have direct impacts to the collaborations that I was describing with allied countries. We are all living through right now the Russia-Ukraine conflict. I had to experience the impact of this through some of the work that I do with a different business that I have. We had hired a number of software engineers out of the Ukraine to help develop different portals for our my insurance company. When the conflict broke out, they all had to be relocated and they all had to move to different locations, which put a halt to some of the work that we were doing. We're now in a position where that has gotten back on track. But what if this was to happen with a China-Taiwan conflict? What if this was to happen where the all-out war was to break out in the Asia region, where it impacted access to India, where it impacted access to South Korea, where it impacted access to Japan? We are heavily reliant on many of these different countries. So not only do we have to observe our own political framework with government budgets and the such, but there has to be an awareness on how like I said, the ripple effect with some of these conflicts around the world impact our ability to not only acquire the components that we need, but to ensure that we don't impact our overall supply chain for the sustainment of our ecosystem.
No, it's very well thought out and thorough there. I agree with you in many senses. I think the pandemic has taught us one thing, if I may make the observation that semiconductors are crucial to the success of any nation's economy as well as security. And yes, current geopolitical situations have kind of dictated that we all look into this more seriously and make some plans in making ourselves much more resilient. But even if those things cool down, it still is an important area for the US government, or for that matter, any government, to be involved in and investing in, because the next problem might be around the corner and it may be something else. So you're absolutely on the spot there. So Dan, thank you. It has been very insightful and very informative. Great discussion. And thank you for joining us on Circuit Talk.
Raj, it was a pleasure. I really appreciate the opportunity, and thank you very much for not only the challenging questions, but the insight from your perspective on our discussion. So thank you.
Thank you. Enjoyed it.